This week, the one, the only Mr. Joff Thayer, security analyst at Black Hills Information Security, will deliver a technical segment on IPv6 tunneling. In our second segment, we welcome back Terry Dunlap, co-founder at Refirm Labs, to talk about IoT security. In the security news, hackers are exploiting a 5-alarm bug in networking equipment from F5. Yeah, I don't know if it's a CVSS score of 10. I don't know about 5-alarm. Cisco Talos discloses technical details of Chrome and Firefox flaws. Palo Alto Networks patches a command injection vulnerability or 2 or more in PanOS. There's a Zoom zero-day flaw that allows code execution on victims' Windows machines, and how the Trump administration is looking to ban TikTok and other Chinese apps. All that and more in this episode of Paul's Security Weekly.
This is Security Weekly, for security professionals, by security professionals. Broadcasting live from G-Unit Studios in Rhode Island, it's the show where exploits run wild, packets aren't the only things getting sniffed, and the cocktails flow steady. It's Paul's Security Weekly. Are you an enterprise dissatisfied with overpriced analytics software that can't keep up with modern data? If so, then GravWell is the solution for you. GravWell is an unstructured data analytics platform for enterprises who demand total data visibility across their network. GravWell lets your security team go beyond the SIM and fuse data sources to correlate and answer questions you didn't know needed to be asked. Go to gravwell.io/Security Weekly for an unlimited data trial and gain uncompromising visibility today. The biggest problem in security that remains unsolved is flat networks inside the cloud and data center that allow threats to move laterally and compromise vulnerable targets. But microsegmentation using traditional firewalls is too complex and time-consuming. There's a better approach: Edgewise Zero Trust Auto Segmentation. Edgewise is impossibly simple microsegmentation. Using the identity of machines and software that are communicating, Edgewise offers the strongest protection that adapts automatically to changes. Protect any application in any cloud without any changes to your network by visiting securityweekly.com/Edgewise.
And welcome to the show. But first, let me introduce you to a man who tries the trick with butter knives, alcohol, and Stuxnet. You won't believe what happens next. Paul Asadorian.
Welcome, everyone, to Paul's Security Weekly. It's episode number 657, recorded July 8th, 2020, right here in G-Unit Studios in Rhode Island. And here with me in G-Unit Studios, to my left, is the doctor. Dr. Doug White is in the house.
I'm here.
Wearing one of arguably my favorite t-shirts.
This is, I know you like this one.
Yeah.
So this is, you can't lose with Mr. Meeseek, Stormtroopers, Wookiees, the whole
it's
thing.
just hilarious.
It takes a second to get. A lot of people look at it and go, "What?"
If you haven't seen the episode, it's.
Well, if you haven't, you have to see. Yeah, there's a whole bunch of things you have to know here.
Right. On the lines remotely, Mr. Tyler Robinson is here. Tyler, I sent you a Slack message. I don't know.
I'm still trying to recover from it.
I've been saving that one for like the right moment. Like, when is the right moment for that? I don't know. I think it was just now.
I don't ever want to know.
Amazing.
Oh, my only question is, why later?
Right? Yeah. Why wait?
Why wait?
Now is the time.
It's a well-known cure.
And why not just for Tyler? Of course, Larry Pesch is here with us remotely. Larry, welcome.
Thank you. It's good to be back. Had a good couple weeks off.
Yeah. Good to
Back
see you.
at it again.
Mr. Lee Neely is here with us. Lee, welcome. Drinking beer.
Good to be here. Cheers.
Cheers. Prost.
Awesome. Having beautiful weather. Looking forward to some fun.
Mr. Jeff Mann is here with us.
So looking forward to hearing Joff talk. I got my Joff Thayer shirt on. I'm ready.
Oh, nice. You came dressed for the occasion. Of course, Mr. Joff Thayer is here with us. Joff, welcome.
G'day, good evening. It's great to be here, and we're going to talk about some techie stuff. I love talking about techie stuff.
Love it.
Techie stuff. So that should be fun. Wait, is my camera blurry, or is that my glasses?
No, but your words are.
It's focusing in and out. Well, it's all good. I want to get into this, so let's do the announcement. With all the recent changes to Black Hat and DEF CON, we realize we can keep doing what we do best.
Host virtual podcast. What were you thinking? I'm proud to announce Hacker Summer Camp 2020 at Security Weekly, the virtual live streaming event August 3rd through the 6th. If you work for a vendor and would like to tell the world about how your product is awesome and better than anyone else's, you can go to securityweekly.com/summercamp 2020 and register for, or actually submit your information to do a micro interview, as we always do at Black Hat, except we won't be in Las Vegas. We'll be here in the studio. You'll be on via Zoom. It'll be almost as good as being in person. Mr. Joff says no intro needed. He's a security analyst for Black Hills Information Security. There's no introduction needed for Mr. Joff Thayer. Welcome, Joff.
There's several precautions that are needed, but
yes,
introductions not
Yeah,
necessary.
that's right. Several precautions.
Gotta have your
maybe
shots.
Some, warnings. Particularly, keep your interns away from me. But did I say that out loud? I was thinking it. Anyway, no, it's good to be here.
Shots, Joff. It's okay.
It's all good.
So, are we doing this now?
Yes.
You want me to do this
Yes.
technical segment?
Yes.
Paul and crew really means Sam and Andrea came to me and goes, "We need a tech seg. You got to help us out." And so we're going to do a technical segment, a little bit on IPv6, but we're going to do IPv6 in a quick and dirty form. We're going to dabble in
how I like it.
IPv6. So I think without further ado, I will attempt to share some screen here. Let's see if I can do this.
Show us something, Jeff.
Whip it out.
I will. I swear to God, I will. Oh God. Sorry, I have to go through the Mac
Show
OS open
me
system.
the money.
God damn it.
Don't you love it when Mac OS says, "No, I'm sorry, the kernel driver says you can't do that." It's like, seriously? I really would like to share my screen right now.
I guess the kernel driver wears the pants in your family.
Apparently.
Colonel.
The Colonel wears the pants in his family.
Okay.
While we're stalling for time, can anybody explain to me what happened to IPv5?
Oh, I can actually. IPv5 was the real deal, to believe it or not, right? Can anybody see this presentation-looking thing?
Yes.
I thought
Okay,
that said
so,
dabbing with IPv6.
I did too.
Okay.
That's what I thought it said.
Technology.
So I named this presentation "Dabbling with IPv6 Segment Technologique." I was feeling French this afternoon.
Fancy.
Yes,
Ooh
voila,
la la.
mon ami. Okay, so here we go. First of all, what happened to IPv5? It did exist, actually, Jeff. Believe it or not, IPv5 was actually a video or real-time IP kind of standard that several vendors experimented with. They were trying to solve the QoS problem. We're talking way back in the 90s, and they actually experimented with IPv5, which was basically IPv4 with QoS mechanisms layered on top.
Interesting.
What did you
and-
experiment with in the 90s, Jeff?
Well, we're not going to talk about that because to do so would be unreasonable disclosure.
Very well put. Please continue.
So, IPv6 dabbling really quick. So, just, first of all, I am not on God's green earth going to try to repeat my webcast and blog stuff that I did back in May 2020. I did a very comprehensive blogcast. That's funny. Blog and webcast subsequently on V6. And if you haven't seen it, then go out and read it and watch it in the next 30 seconds, and then we'll talk about IPv6. I know that's impossible. You have to put me on like 20 speed. But yeah, this is going to be a brief tech segment that is a bit of a follow-on to some of that material. Personally, and I am biased, I think I did a really good job on that. And if you haven't seen it, I would highly recommend checking out both the blog and the webcast.
It's really good. I actually watched it the other day, so I had been looking for it to come out, and I would highly recommend it.
Love it.
So
Go ahead,
thank you,
then.
Doug. Thank you, Doug. Man, I know I have friends, right? Highlights in 20 plus seconds. With IPv6, broadcast is gone. Dun, 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 dun. Right? What? Broadcast is gone. In a network world, we're used to broadcast. What is going on? Right? IPv6 was designed essentially in the 90s, and multicast is everything in v6. And what does this translate for you? Well, it means that architecture networks really well. And I have a reason for saying that. If you have a network where you are carrying like 40 VLANs over a trunk in your core network and you turn on v6, I guarantee you your network is going to fall down around your knees. I guarantee it. And the reason is that everything about IPv6 depends on multicast functionality, and all of switching infrastructure today and routing infrastructure is multicast aware, and the ternary cams in your switches, the memory in your switches, will try to track every multicast in every segment in your network when you turn on v6. Multiply that by the fact that any interface in your network actually, for v6, will essentially have multiple IPv6 addresses. And you may have many hundreds of those in a subnet. You will literally DOS your network if you don't have a well-architected network.
Hey, Joff.
And this is kind of a challenge.
I have a question. Yeah. Correct me. I have two questions. Correct me if I'm wrong. DHCP is a broadcast protocol on IPv4, correct?
That is correct, sir.
And so if there is no broadcast, that means it's DHCP v6 is a different thing that uses multicast for v6 networks? Or does everyone just get a statically assigned IP address because we can afford that now?
Well, the answer to that is that depends. Mm-hmm. Okay? Most IPv6 subnets are going to be /64s in the world. Mm-hmm. Now, what does that mean? /64 means the subnet, I shit you not, the subnet that you are living in is twice as big. Actually, that's
so is
not
that
really
is that like 2/32s?
No.
It is twice the size of the IPv4 entire network.
Oh, I'm laughing at my own joke. Sorry. Continue.
Yeah, you are in fact a legend in your own mind, Paul Exodorian.
Paul, it's twice as big as /63.
Right.
Come on now.
Yes.
Yeah, I know. Thank you,
Math is
Jeff,
hard.
for correcting my lack of exponentiality. But yes,
I was correcting Paul, not you.
We have a massive address space, and most people will sit in /64 subnets. Okay. Before I get to that, ICMP-v6 is very, very important. These are the 50 bazillion feet highlights here, right? Neighbor discovery matters. Neighbor discovery is a multicast-based protocol. It is the ARP replacement. It does map MAC addresses to IPv6 addresses. Router discovery is also very important. Router discovery enables the routers in your v6 network to actually populate route tables in the endpoints. And everything is multicast in a subnet. And I'm not going to refresh the entire presentation. You can go back and look at that. Security in 30 plus seconds. There's this myth out there. IPv6 is more secure than v4. Not true.
I was taught, I was told
different.
this like 20 plus years ago or something. There was an engineer, and he was really touting that v6 would solve a lot of our security problems. And I believe what he was referencing was the fact that it supports IPsec in v6. Is that correct?
That is correct, right? Everybody was stuck on this idea that v6 intrinsically supports IPsec with the authentication header and the security headers, and it's just built into the protocol. Well, they backported that to v4, so it ended up being the same thing, right? It's no more or less secure than v4. It's a transport protocol. Okay, that's it. But you need to be aware of certain things. First of all, bogons are back. Our friend the Martians, the bogons, are back. In fact, they're back in a huge way. There are only 35 IANA address block allocations to regional internet registries, and there is not likely to be any more than 35 IANA address block allocations, right? It's a huge address space. It's not going to be used up quickly, and so those things that are unallocated are things you should filter.
May I ask a question?
You may.
You just did.
That's true.
Next question.
I'm curious. Paul and I used to work for a particular, vulnerability scan engine company that, in the last couple of years, changed its pricing model to be more, target based. Is there any concern that when you have this much address space, that models built on, it's no longer you just scan a Class C and you're done with it. How are the scan engine companies dealing with IPv6 in scan engines?
So great question, Jeff.
That's what I'm known for. I have no answers, but I have lots of great questions.
I actually thought that you would come out with a PCI question, but I applaud you for coming out with an actual technical security question. Well done, sir.
It happens when it's essential.
Well done, sir.
I don't know how the security companies are going to deal with this technically. I suspect I know how they will approach it. There is a way, for example, to send out a multicast ping in a V6 subnet. It's kind of analogous to the Smurf attack. As long as you keep it local, you can get away with it, and that's where the challenge is going to be. They're going to have to put something in the same subnet, because a lot of organizations will filter it to make sure that it cannot go beyond local. But if you send out a multicast ping to the FE prefix, actually it would be FF, FF 05 or 01 or 02, depending on the scope, you will get responses from everybody in that subnet. And that's the beginning of the scanning issue. You cannot reasonably do a search in the IPv6 subnet for all of the addresses, with a caveat, though. There is the concept of EUI 64, and Enhanced Unique Identifier 64 means that MAC addresses get factored into and mapped to both link scope local and global addresses in V6. And if you use those and you leverage the idea that you probably have a specific vendor supplying the NICs in your organization, then the address space to search for addresses in the link scope local and even potentially Slack assigned global routable IPv6 space reduces to about 24 bits.
Does that still mean I have to be on the same subnet, or no? In that case, it sounds like I don't.
No, sir. You would still have to be in the same subnet because, for the globally unique address, you would have to be in the same subnet. For the link scope local, you would not.
Well, that begs the question. How do you subnet in such a vast address space?
You don't.
Well, you do and you don't, right? What people do is you will see sparse allocation. You will see at organizations receive /48s, which is a huge address space, and then they will subnet out /64s from that /48 address space allocation. That's the standard delineated subnets that are going to be in V6. Now, some people may choose to subnet out smaller, but the net result is you will have a very sparse address allocation inside of that /64. And so discovery is going to be a matter of having an endpoint that is able to transmit a multicast ping or some equivalent inside the subnet. Otherwise, you will not be able to do discovery linearly, or even with a binary search tree algorithm, you would not be able to do discovery in real time. It's a huge address space, right?
That's what I keep coming back to, and apologize for being a dinosaur, but back in my pen testing days, we spent a lot of time, hunting down who owned what domain and did they have a class A, B, or C, because back in those days there was no private addressing, and so the IP addresses were our targets.
Yep.
Is that totally blown up in IPv6, or what is? I mean, is there a concept of a class A, B, C in IPv6? How do I, Acme company, go out and procure IPv address v6 space, and how much do I buy or lease,
so
whatever?
As an organization, you're going to be given a /48, which means 128 bits minus 48 is what you get to allocate out, which is huge. Yep. That's just going to be standard. It's class full. It is not class less. It's very unlikely that we will be in a class less or cider kind of space in v6.
Mm-hmm.
There's just enough space that we don't need to do that, okay?
Yep.
And so when you're given a /48 as a unique organization, more than likely, as the diagram shows here, you will subnet on the 64 bits, and every subnet you get will have literally up to 2 to the 64 addresses in it.
Yeah, somebody dropped the actual number in the Discord. I don't even know how to say it.
It's huge.
Damn big.
All right. Let's not get hung up on that. I tried to make this quick and dirty, but it was a good discussion. If we can move forward, that would be fantastic.
No, I don't want to. I have more questions. But no, go ahead, Joff.
Yeah. Okay. Security serious bottom line issues. Perimeter filtering of IPv6 and IPv6 multicast are going to be very important. If you don't want to participate in global multicast, you need to filter it. And these are the prefixes that start with FF. And if you filter the global multicast scope, then you just drop it at your perimeter. IPv6, ICMPv6 is extremely important because it depends on multicast, and it will determine address discovery and router advertisements inside your network, and it is extremely important to have it functional inside the network, and it's also extremely important to filter it at the perimeter. Again, I don't want to do the whole presentation. Go to the presentation to take a look. Protocol normalization is an enormous issue as well. IPv6 has this concept of protocol headers that can be extended essentially after the layer 3, OSI layer 3 header. So they call them extension headers, and TCP and UDP are part of that header set, but there are other headers that can go in there, such as a routing header to do our good old favorite strict source routing or loose source routing operations, or other informational protocols. So protocol normalization in that gap between layer 3 and 4 is going to be extremely important. Anti-spoof and bogon filtering is also going to be extremely important. And then really, really important here is inside your network, when you have subnets, if you do not filter router advertisement, which is an ICMP v6 packet, from your endpoints, then your endpoints have the ability to populate route tables in the other endpoints of the same broadcast domain. I really should say multicast domain. Okay? That is significant because router advertisement as part of the neighbor discovery protocol suite literally populates the route table of your endpoints. And so it's something to be aware of.
I have
Does
more
your
questions.
ISP carry v6?
Yes. No.
No, yes. Don't know.
Yes. Most of them do, I think.
Yes.
Mine doesn't, interestingly, because I actually asked them when I was actually entering this topic. I said, hey, guys, give me a v6 allocation. They said, dude, you're our most advanced user. Like, literally, you are our most advanced user, and we don't have any v6 we're routing. I was like, crud. Okay. So this is a problem. why is it really a problem? Well, everybody knows that is our audience member that in 2011, IANA ran out of IPv4 allocations. Now, it wasn't a big deal. People threw their hands up and they said, well, okay, crud, we're out of V4. Not really, because all of the regional internet registries still had address space. We got AFRINIC, we got APNIC, we got RIPE, LACNIC, we got ARIN. Everybody still had address space. Guess what year that address space is predicted to finally run out? Right now.
I was going to say 2020, because 2020 is
wrong?
that kind of year.
Because what else could happen in 2020, right?
On top of it all, we run out of friggin' address space for V4.
Yep. This year is the end of V4. Shit you not. This is it. We are out of V4 this year. The regional registries have exhausted every last block they can possibly allocate. This is a predictive model, but it's turning out to be pretty true. Okay? We don't have a choice. When an organization calls up and says, give me a V4 block, Aaron in the US is going to say, you've got to go out to the third-party market and see what you can get, because we don't have any. Okay?
There's a stand in Tijuana that sells them.
So I do have another question, Joff, and I'm just, as a practical matter, not even getting into the security of things. I'm a large organization, and I've been doing private addressing within my enterprise for years and years. And maybe the first question is, why would anybody switch over to IPv6 if they've already got a V4 address? Is it necessary to readdress everything on the inside of your network if you've converted over to IPv6, or what happens to all the private network addresses that are already out there from so many companies?
Good question, Jeff, man. It's a difficult question.
Well, I got nothing but difficult questions.
Because first, network address translation is, and I love Marcus Carey, don't get me, Marcus Ranum, sorry, wrong Marcus. Don't get me wrong. Network address translation was a savior to the V4 world and is an absolute godsend, but is 100% not needed in the V6 world.
Yes.
I get that.
Dual stack is a challenge. It is twice the work and half the fun, is the way I like to put it. What I mean by dual stack is your endpoints have V6 and V4 both on them. Right. You just doubled your information security workload. Okay? There is no such thing. Well, let me rephrase that. There is no real need for network address translation inside of V6 unless you feel like you want a concept called address independence. Address independence means you just want to carry the same address block around with you and you want to do some translation. But aside from that, the fundamental precepts around NAT were driven at address conservation. This is not a need in V6, period. It doesn't exist.
Yeah.
Okay? So what is your choice? Your choice is to do dual stack in transition and double your security workload while you do it. What I think most people are doing is kind of ignoring the problem and focusing on their internet-facing assets first, deploying pure V6, or at least this is the way I would do it, and ignoring the internal network until they have to address the issue.
Pun intended.
So so that's not a dual stack, but there's some sort of translation that goes on. There's a gateway. Thank you. Between the external IPv6 addresses and the internal IPv4/private addresses.
Right. So
I guess what I'm getting at is, why would
mechanisms.
anybody in their right mind go out and readdress their entire enterprise when you're talking, tens if not hundreds of thousands of nodes? That seems like it would be a time-consuming task.
Well, it is and it isn't, right? If you deploy v6 in a subnet and you use SLAC, which is stateless link address auto configuration.
Yeah, we're talking on Slack right now.
Your v6 endpoint will receive an address, a globally unique routable address. You need to secure that. You can secure that, but you need to secure that with the right and parallel security mechanisms that you would use in v4. The end result, in my opinion, is that the in-between state, the dual stack state, is going to be and will continue to be, from a security perspective, extraordinarily painful. I don't see another way around it. You will end up dual stacking, and you will end up having double policies in your filtering devices to represent both the v4 and the v6 traffic. Let's talk about tunneling.
I'm beginning to understand why it took 20-some odd years to get this thing out. But
Yeah.
keep going.
Yeah, forklift upgrades suck. Let's just put it into one sentence, right?
Yep.
There are a number of v6 tunnel brokers. There's a wiki out there. You can go look them up for yourself. Many of the tunnel brokers are now actually moving into an end-of-life state, because the assumption is, now that we have reached 2020 and the IPv4 rundown model is actually showing us that we are truly out of IPv4 space, that people will not need to tunnel v6. Now, what is tunneling v6? Well, tunneling v6 is actually encapsulating v6 packets inside of a v4 packet and sending them to the tunnel broker, where they get decapsulated and dropped onto the v6 backbone and appropriately forwarded on. Now, you can do this if you want to dabble with v6, and that was the entire point of my presentation. You can go to the wiki, you can look up tunnel brokers. Here in the US, the guys at Hurricane Electric do a really good job of this, and they still have it up and running. And in fact, if you register for an account at Hurricane Electric, you can acquire up to 5 different tunnels from the Hurricane Electric guys. And when I say 5 different tunnels, they will allocate you 5 different /64 networks to whatever tunnel endpoint you want to deploy. Meaning, you end up with a boatload of address space times 5, bigger than IPv4, to do with what you wish to do, and tunnel it for free, quote unquote, until they decide to terminate the service. Now, the assumption, of course, is that ISPs will finally deploy v6 and be forced into routing it. We're not quite there yet. Okay?
Mm-hmm.
How do we do some tunneling? Well, we can provision some sort of Unix variant, or Windows if you care to, but I'm going to show this on Unix. Pick a system to deploy it on, create a tunnel, and I'm going to pick on Hurricane Electric, although you could choose another one. Configure said Debian, Ubuntu, or other Unix system.
Well, you said Unix, Joff. I was curious whether you're running on Solaris or AIX.
Ah, man, I love you, Paul. You know I do. You know I do.
Did they backport IPv6 to Ultrix?
Come on.
I will pay homage to the Linux term only as much as I need to, but Unix is near and dear to my heart.
Linux is just a kernel, man.
Yeah, it's just a kernel.
I kept calling.
And then what I highly recommend is getting a DNS server up and running as quickly as possible. Now, why do I recommend doing that? Well, have you ever seen an IPv6 address? It is not something you're going to commit to memory, okay? We're talking about 128 bits expressed as hexadecimal in nibble form, and the zeros can be omitted if there are repeating zeros in there, which makes it slightly easier, but it is challenging. Okay?
You could just show us what one looks like, Joe.
Wow, I totally could. So having said
But
that,
he's not going to.
It's on the next slide. I know it.
actually, I'm going to do a live demo. Look out.
God.
Here we go.
IPv6 porn.
Go, Joff, go. Go, Joff,
Oh, man.
go.
All right.
This is
I
gonna
just
take
got to
more
find
beer.
my Skype stuff and stop sharing screen here. All right, Skype, where are you? Skype, seriously, where are you?
It's in the other corner, Joff.
Switch screen to another window.
It's
I
an
am switching
IPv6
to another
subnet.
window.
You've got. How do you pronounce that term that we came up with?
Actually, before I switch to that window, let me switch to the browser tab I had open here, if I can find it, and show briefly Hurricane Electric's interface.
Whoa.
Uh-oh.
I'm scared.
Oh,
It's the IPv6 police.
What did he do? Switch to his IPv6 tunnel?
Joff must have crossed the streams again.
I see.
boy.
Reconnecting. There is a poor network connection. Uh-oh.
He's trying
Oh,
to
dear.
put it. He's trying to put a 64-bit address into a D word.
Quick, somebody
What's
come
this
up with an
like
IPv6 address.
IPv4 address.
FF00 colon 0. That's an IPv6 address.
You sound like that old telephone operator whenever you get the number wrong.
At the tone, the chime will be FF00 colon 0. If dates and times were reported only in hexadecimal, Joff has gone into IPv6 oblivion. Getting out of
We're
there is going to
sorry.
be hard.
Your call cannot be completed as dialed. Please check the number and try again.
Ooh,
Oh,
that
something's blinking.
There was multiple Larrys there.
Leave a message.
I didn't do it. I swear.
We were just seeing multiple Larrys, and it was like freaking us out.
When my kids call me with computer questions, I
I'm
answer the
back.
phone like a help
I'm
desk.
back.
Hey,
Apparently,
he's back.
Skype not like that.
When you exit? Yeah, that's what happens.
When I actually asked it to do something useful, right? Love
You mean exit?
All right, so hopefully you guys can see a little bit of the Hurricane Electric interface. So let's continue on the demo. All right. So you create a Hurricane Electric account, you log into the account, and these guys have been great. You can create a V6 tunnel through these guys, and I've got several different tunnels created, and I'm just going to select one of them here and show you the tunnel configuration. And the nice about this, you can select your OS with these guys, and I don't know how long it's going to last. Remember, the V6 is going native, right? But your OS, I'm looking for Ubuntu, and it shows you the configuration you need to put in to tunnel 6. Okay? Can you see?
Mm-hmm.
Okay, good. So now let's switch our share window over to another system which I've configured to actually tunnel V6. All right. Did that work? Here we go. So this is the system. It's a digital drop. Can everybody see that? All right. And
Yeah.
normally you just an Etsy network instances here. However, some maybe that what did you do to us recently? Well, in the last couple of years. Okay, you guys still there?
You're clipping
Yes,
out.
clipping.
Yeah.
Must be your network.
Okay. As long as you're still. Anyway, what I did was converted the configuration in that plan compatible YAML file.
It doesn't seem to be getting
Sorry,
any
I'm
better.
standing by for a second.
Are you routing through China?
I'm going to change my shirt in a minute.
Ooh, dirty.
Okay, can you hear?
Do it real slow, Jeff.
Can you?
Yeah, maybe reconnect. I'm not sure what that's from.
I think he's gone.
I mean, it's irony at its finest, right there.
Bye bye, my Joff. Goodbye.
Well, I think the irony is that the screen we're seeing of his terminal session shows him logging in from an IPv4 address. I thought this was an IPv6 segment. Like, really?
Remember, he's got both.
This is true. This is true.
So poll the panel. Who in their right mind is going to convert to IPv6? It just seems complicated.
No one is until they have to.
Yeah, that's how
For my
things go.
C2 or for my personal network?
Well, yeah. I mean, if you have internal networks, that's another matter.
I mean,
Command and control on IPv6 and or use is kind of nice.
The typical, average company out there.
No way. Not till you have to.
Do this.
So, but to Tyler's point, though, do they block it egress?
You'd
Because
have
I
to.
do. Because I do.
Well, you'd have
right?
to block it egress.
Yeah.
I mean, otherwise it's routable because there is, as he was saying earlier, there's no NAT in IPv6. So all the addresses that are issued are fully routable worldwide. So you're going to have to, one of the big security things you have to do is you have to block at your border in both directions if you don't want, because otherwise somebody could scan an address from anywhere.
Like, we don't have an IPv6 from our provider, right? So I basically do that. I block it in both. So like,
so that would be typically
my final like allow rule out in PF sense, right? You can say IPv4,
right,
and then the one before that is like IPv6, like block and like maybe log. So I can check it, right, every once in a while. And Tyler, to your point, that C2 stuff, right, that you got to make sure you're doing that stuff. I suppose I would need an address on the outside for it to get out, or no?
So I was thinking with all this, no more broadcast and the ARP changes. Last week we were talking about the firewall that used ARP poisoning to work, and we've other things we've done for hacking. We use I guess that's all out the window. No more ARP poisoning.
It's a multicast poisoning.
Yeah.
Back.
It's Joff.
Hooray.
Can we continue?
Sure.
Go for it.
We're tired.
Actually,
we're
how about
tired
just
of
step back
treading
a little
water.
bit? Tell us more about NetPlan.
All right, so let me go back to this. So Ubuntu kind of moved away from the Etsy network interfaces thing, and they moved us into this NetPlan space, which is a YAML file instead of the Etsy network interfaces thing. And unfortunately, Hurricane Electric right now, it is a free service, free as in free beer. They don't have a YAML version, so I just converted it to the YAML version here for my V6 tunnel. All right, so here's my tunnel configuration. It's the remote endpoint that's in Ashburn, Virginia, the local endpoint, which is on the DigitalOcean droplet, okay, a V6 address at this end, and then a gateway at the other end, which is a point-to-point V6 link. And then I put in a name server address of : 1, which is localhost in V6, okay? So, and you can NetPlan apply this, and once you do that, once you look at the interface, you'll see that there's an IPv6 interface that comes up, okay? Everybody with me? Is everybody still hearing me?
Yes, we can hear you fine now.
I don't see IPv6, I see HEV6.
Yeah, HEV6, that's the name of the interface. So I can ping
Hurricane Electric, gotcha.
Hurricane Electric. I can ping 6 my local address to double check the connectivity, okay? And then I can ping 6 the remote address to double check the connectivity. And I have an active V6 tunnel at this point on this system, okay? All right, fantastic. I can also look at the route table. You can use netstat in Linux. Netstat-nr6 will give you the v6 address family. And you can see the gateway of last resort here is // 0, pointing to the remote gateway, which is indeed that HEV6 tunnel interface, showing me that all my v6 traffic is going to go to that tunnel allocated with that /64. So I'm set, right? I'm up and running now with a pretty simple configuration that actually gives me a globally unique routable v6 address on this HEV6 interface. Now you'll notice there's another address here as well. The other address is what's called a link scope local address, FE80, and basically some kind of address that's usually derived from the Ethernet address. In fact, do we have Ethernet? No, I don't see it there. But anyway, so link scope local is used for local operations. Global is globally routable. That's the short version of it. Now, the next step you really want to do is install bind 9. I've already done this in advance, okay? And when I installed bind 9, there's a root hints zone file which refers to the root domain servers for DNS. I edited this and made sure that it was only v6. So you can see a.root.servers.net is a v6 address, b.root.servers.net, and so on. They're all v6 addresses in the root hints file. And when I look in my named.conf.default zones, I'm actually going to change this to the hints v6 only in the zone file, and then restart the bind9 server. Okay, now bind9 is a DNS server. Now I can use dig to look up an address. Now I'm going to look up an address with a quad A. And I'm going to look up Google because Google absolutely has a v6 presence.
Yep.
And this is the address of Google, okay? 2607 F8B0, etc., etc. So now to prove that I can actually talk v6, I can ping that address from my v6 box, and I will get replies, meaning that I am natively talking v6 now across the internet. All right, so I've successfully stood up a tunnel, and I am talking v6, which is actually really v6 inside of v4, and in fact I can even TCP dump this just so you can see it. All right, oops, that was not good. Proto 41, which is the tunnel protocol, and then I can ping that address, and then on ETH0 you're going to see encapsulated v6 packets inside of v4 actually occurring there, okay? Or I can TCP dump, and this is kind of fun, the HEV6 interface directly, and you can see that ping traffic, okay? Now, here's the fun part. I don't know if you call it fun. If you ever try to use TCP dump on a v6 interface, on a v4 interface, let's say on your regular network, what are you used to seeing?
A lot
Not
of
a trick
noise.
question.
Broadcasts, ARPs, the net, what?
Yeah, exactly, Lee. You see a ton of noise. What do you see right here when I'm not transmitting?
Nothing.
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 Cockroaches, no
now let
legs
me do
can't
a
hear.
DNS
I mean, what
lookup.
the heck?
Let me do a DNS lookup, okay? Dig at : www.mit.edu, which also happened to have a v6 address. Okay? It succeeded. Okay? Now I see all of that DNS traffic. Okay? Fantastic. So we know that we are talking DNS with that lookup. We know absolutely, in fact, we've talked a lot of DNS Let's go back up. We've talked a lot of DNS, right?
Wow.
We've really talked a lot of DNS. All right.
That's just from one query?
It's a DNS denial of service, like self-abuse or something.
Well, remember, I'm running a local resolver. So what happened was looked up on the local resolver, right, and then it queried it.
Queried the root.
And it did a TCP
and you're dumping
send.
everything, yeah.
Okay, and it was a TCP transaction. So it's a little slower in V6 because a lot of DNS is going to be TCP. It exceeds 512 bytes. It's not going to be in the UDP space, but you will get a DNS lookup there. But I was actually stunned outside of my local traffic, and I shouldn't have been stunned that, oh my God, you've got a V6/64. It is a tiny speck in a vast ocean of nothingness. Nobody is trying to hit you. There is none of the backscatter traffic. There's none of the scanning traffic. You're literally just sitting here in your own little V6 world, right?
For now.
For now.
Yeah.
Don't get complacent.
Right? And we could try to connect to google.com on port 80. And sure enough, we end up with a TCP SYN packet that goes out to Google's address, a SYN-ACK, and then an ACK of that SYN-ACK. And there it is, right? We are 100% talking V6.
Mm-hmm.
Right? So now I want to show you one other thing, because we're running a little late, but I'm going to show you one other thing before we finish this fun. I got to find the Zoom client now. Zoom, where are you?
This is where
tempting the demo gods again.
The one other thing I want to show you is a different VM with a different tunnel endpoint that I configured, if I can find it. That's always fun. Here it is right here. All right. So here's another. This is a Kali box. And equivalently, I configured up a V6 tunnel. It's called HE6 right here. And it has another tunnel endpoint right here. And in this case, and Larry's going to point out to me that I'm revealing local address information. And yes, I absolutely am. And if you feel like attacking me, just piss off, okay?
You're not authorized for that type of testing.
Yeah, not authorized. This time I have in the ETSI-NET interfaces of this, and it's sitting behind NAT. And so the endpoint is a tunnel endpoint in Dallas, and the local endpoint is my local NAT address. But it NATs out through to my public address, and here's my V6 address, okay? And again, I've installed bind on this system, so I've set the DNS name server to : 1. All right? Again, I should be able to ping 6 google.com, and I'm in good shape. And then I should even be able to go further and trace route 6 google.com, and we'll get a V6 trace route here that's going out through the tunnel to Dallas, through Hurricane Electric's network, and attempts to trace the Google. Not everybody is giving me an ICMP time exceeded. It's the same mechanism as V4 traceroute. And eventually I get to google.net. You can also, and this will really blow your mind, you can also do a reverse lookup on google.net's address, and it goes to the PTR zone. Let me do this with host, because doing it with dig is painful. It goes to the PTR zone of IP6.ARPA, and it is all of those nibbles reversed 36.00000.ip6.ARPA. I'm not going to read out the rest of them, pointing back to the Google domain in the le100.net, showing you that the IP6.ARPA zone is also up and running. We can play netstat games. I can even delete my default Route 4 V4 gateway if I want, if I'm really feeling adventurous. Route delete default gateway, 0000.
I'm glad you're not the only one that gets the syntax wrong on the route command.
Yeah, always this. Right? I left the route in. Notice I left the route in to the one host that I'm V6 tunneling. And so if I ping 6 again, guess what? V6 is still up because I'm tunneling to my local router and then it's subsequently tunneling that V6 outbound. Okay? So V6 is 100% working here. I'm going to add that route back in. All right. And now I'm going to show you a couple of web resources, which was the reason to come here. All right. Google has something called Google. It's amazing. No, sorry. Google has
Go Ogle.
A Go Ogle, right? An IPv6 resource. But also I found in Firefox a plugin called it's called IPv6, which is kind of fun. But the plugin shows you how you're connecting to the various domains here over what address space. So you can see I'm connecting to google.com over v6, and the other domains involved in this particular tab in the browser are showing no address right now because, well, there's no associated v4 or v6 address presently. There's also a couple of mechanisms to test your v6 connectivity. So, for example, we can use testv6.com, and it will run a test. And yes, I'm revealing my public internet address here on the v4 world, but it shows that my v6 is going through Hurricane Electric. It shows that I have a DNS server that is up and running. It shows that I have 10 out of 10 v6 stability.
Nmap 199.101.
It shows that all of the associated v6 capability that I have, right? So I'm up and running. Google has one of these as well. I think it's called IPv6 test or something. Let's have a quick Google of it. Go Ogle of it. Excuse me. IPv6 test. That's not the one I was thinking of. But anyway, you can do ping tests and you can look up your addresses. For example, I can hit the ping test here and it will show me, in this time I'm dual stacking. It'll show me my IPv4 ping results. It'll show me my IPv6 ping results, right? And just show some basic information on my address. Now, I can go crazy and delete that route gateway again and then refresh that web page. It is available over v6, but now when you do that ping test over v6, you will not get any v4 results. You will only get the v6 results, okay? Oh, come on, give me a break.
Clearly, you need to boost your Windows startup, Joff.
Oh, this is is that like a
OS
it's a cliche,
fail,
right?
huh?
So there it is. Let's leave that alone, since it's being pokey. If we rerun the test, the v6 connectivity test here, just for fun, okay, we're going to find out something interesting. Unable to connect. Now, why are we getting this on a test IPv6.com domain? Well, let's dig that address. What do we see? And this is kind of the issues you run into. It's only available over v4, and I deleted my v4 route, and therefore I will have no connectivity to that resource.
That's bizarre.
Because there is no v4 route, right?
To a IPv6 test domain.
So an IPv6 test domain has no v4 connectivity, which I find to be hypocritical. I'm not sure what the right word is, right? Now, when I hit this IPv6test.com here again, this one clearly does have v6 connectivity. Let's double check that. Let's do a dig on that. And this time, let's make sure we do :1 -type AAAA. All right, it still says I have no v4 connectivity. I must have had it cached. There's no other excuse for that. All right, so let's add our route back in. All right, let's go add default gateway back in. All right, let's refresh this thing, and it should come back, right? Oh, there were two different domains. My bad. One was IPv6test.com. Okay, let's do that. Sorry, I messed that up. IPv6test.com, in fact, does have a v6 address, and so I can delete that route for the v4 stuff, and it will still indeed appropriately look up the IPv6test.com instead of test.ipv6.com. Okay. Because we have a v6 address. Okay. So you're seeing some of the challenges here of dual stack. Dual stack is going to be painful. It's not going to be easy. And it is going to be a transition period we're going to have to live through and just tolerate. And it's going to double our work, frankly. So
exponentially.
I'm not super happy about that. I'll be honest with you. All right. So having said that, I think I should wrap up. Let me just share one last thing on the PowerPoint, and that's a few resources that you want to look at. And I really, really do encourage you to check out my presentation, which is the webcast on how to securely start deploying, the blog that's associated with that, a number of helpful resources, and which APNIC and, I have to say, Australia has done a good job with that, with this resource. Check out some of that stuff. It's really good. And then from the security perspective, if you really want to get into some v6 tools and discovery, absolutely go check some of the Kali stuff that's out there with information gathering and stress testing. There's some really good stuff there. In particular, because you have the ability to do link scope local v6 inside of a v4 world, it is by default assigned that FE80 address. There are some lateral movement opportunities using v6 in a v4 subnet. So think about that. Think about exploring that, right? And I've taken more than enough time at this point.
Joff, thank you so much. That was
awesome, Joff.
Loved it. With that, we'll take a short break. Come back.
So cool.
With Terry. Stay